Welcome to the May edition of the GoldSim Monthly Webinar. The topic of this webinar is time series analysis with GoldSim. My name is Nick Martin and I work at GoldSim Technology Group. We're going to start out just by going through a few slides and talking a little bit about time series analysis in GoldSim, and then we'll look at a few GoldSim models, mostly from our model library. If you have questions at any point, feel free to use the web meeting interface and ask the questions, and we'll have some time for questions at the end as well. We're going to start out today by briefly touching on what we mean by a time series. So, time series is a collection of observations made sequentially through time. And here we're generically talking about a time series. But in terms of GoldSim, our GoldSim model, there are a couple places where you could have a time series. There's the time series element, which is meant for data entry or data time series values. And then there's also the time history result element, which is used to collect simulation results over time, so to collect simulated time histories. So, the time series element, as I mentioned, usually stores or holds a data time series, which is just a sequential collection of observations. Time history result element provides access to simulation results across the simulation time period. So then the time history result element holds a sequential collection of observations where the observations are calculated or simulated values. So both are time series. One is data, one is simulated values. So time series analysis itself, time series analysis is kind of a special class or an independent class of statistical analysis. Much of statistical theory is concerned with random samples of independent observations. One thing that is unique or identifying about time series analysis is that successive observations are not usually independent. They're correlated in time, and much of the analysis is geared towards either explaining that correlation or taking that correlation into account. So for any time series analysis, or a time series analysis is sort of a subject within statistics, it can be sort of divided up into four classical objectives. These are listed here as description, explanation, prediction, and control. Description usually includes very basic stuff like plotting, visual analysis, and descriptive statistics. Explanation is when you're doing an analysis mostly to try to explain perhaps the variation in one series based on observations in a different series. So a classic example could be perhaps variation in precipitation based on observations of temperature and relative humidity or something like that. The prediction or simulation part would then be looking at forecasting or simulating a synthetic time series based on observations made, so based on a data time series or perhaps based on a model developed as part of the explanation of a time series or an explanation of the variation observed in a time series. The final objective, the control objective, is sort of comes into play. It's like analyzing, if you're meeting a criteria over time based, whatever that criteria may be, but it often comes into play with monitoring and control applications. In terms of GoldSim, as probably many of you know, one of GoldSim's big strengths is that it's a dynamic simulation framework, and so GoldSim is really good at simulating values or estimating or predicting values across simulation time. So in terms of our time series objectives, the simulation or prediction of time series values is often the main time series focus of most GoldSim models. Most GoldSim models then usually simulate or predict values over time and would use a time history result element to collect these values. And often, of course, there's many time history result collecting many simulated values. There are many specific example models in our model library on the website, which show various methods of generating synthetic time series. A couple of those are listed here. These are both just ways to generate a synthetic or stochastic precipitation record, but many other example models exist, and this is sort of the commonly used implementation of GoldSim in terms of time series. Today, however, we're going to talk a little bit more about analysis objectives number 1 and number 2, and that's describing a time series and perhaps looking at ways to analyze the time series in terms of explanation of basic statistics, as well as perhaps looking at the variation compared to another time series or between two time series. Okay. So the description and explanation objectives are fairly different from what you would see in a dynamic simulation. They're essentially a static process, and the easiest way to think about that is probably that you generally need the entire time series before you can describe or explain it. If you wanted to plot the entire time series, it's of course helpful to have the whole time series before you could plot the entire time series. In a similar way, common descriptive statistics say the standard deviation of the values in the time series. For that calculation, you would need the mean of the time series, and so you would need to be able to calculate the mean for the entire time series before you could calculate that statistic. And so that's kind of what I mean by they're static. You need to have the whole series, and you're kind of looking at the whole time series at once. It's not the type of calculation where you'd be moving through simulation time and calculating a value here and there. Okay. Although GoldSim's strength is definitely dynamic simulation, it does have static calculation capabilities, and these can be employed for the type of time series analyses we're talking about here. These static calculation capabilities are a little bit different way to implement GoldSim from the more typical simulation. And there's some tricks or some components or interfaces in GoldSim that you can use for this that aren't used as frequently, and so we'll spend a little bit of time today looking at some of the models from the model library in order to show some of these tricks and common ways they could be used. But before we dive right into a few models, I just briefly want to go over a couple of sort of the common built-in analysis and description components in GoldSim, as well as a few other specific element types that can be helpful in this type of time series analysis. So probably the first and the most commonly used element would be the time history result element. And so the time history result element, of course, provides a plot of a time series. Generally, it's a time history, so a simulated time series, but it could also be a data time series from a time series element. Another sort of basic time series analysis component is, summary statistics, and so that would go into both sort of description and analysis objectives of a time series analysis. But GoldSim has built-in reporting periods, which are, fairly easy to use, and they then would provide you statistics based on those reporting periods. These would be like annual or monthly statistics, and so this provides a very easy way to get out some summary statistics for over different time intervals from a GoldSim simulation. Another sort of built-in functionality in GoldSim that's very helpful in terms of time series analysis is the vector operations and calculations that you have access to and they generally would come into the equation, when you're working in sort of the equation or input dialog in a function, you have right click and you can have access to a whole range of built-in array matrix vector operations. The example shown here, it's something we will continue to look at as we look at a few model library models, but you see we have a time series, and that's this flow rate 99 time series. And that time series object is converted to a vector. And so you can see in the expression dialog here that the way that's converted is that basically this time series, this flow rate 99 time series, is a daily time series. So there's one value for each day, elapsed time. Then in the equation shown in the expression property, you can see that we're going through that time series using the row iterator, which is a built-in iterator for a vector. And so what this is doing is just saying, okay, each day take the value from the flow rate 99 time series and put that in this vector. Of course, day 0 would be vector index 1, day 1 would be vector index 2, and so forth. And so this row item is just going to increase. Basically, this equation tells GoldSim to loop through the time series using the number of rows or indices defined in this vector using the array label set time points. Okay, so that's kind of an advanced functionality of GoldSim, but one that many of you are probably familiar with. And essentially, it kind of provides a built-in way to loop across a vector. And here that's used to transform this time series to a vector. Once it's the vector peak flows, then you can use all of these built-in analysis functions for vectors and matrices to calculate, various statistics. In the example shown in the current slide, that's the calculation of the mean of this vector peak flows. And you can see the equation there. So it is very easy to use, and it provides, a very strong tool for analyzing time series. So now we're going to move on to some of the element types perhaps that are used maybe a little less frequently in GoldSim, but the multivariate result element provides a good way to look at correlation. And so as we discussed in the initial sort of overview of time series, one of the things that makes time series stand apart from other sort of statistics and statistical analysis techniques is that we're expecting correlation, some sort of correlation probably according to time order. So we're expecting today's value to be somewhat dependent on yesterday's value. Okay? And so the multivariate result element provides a way to look at correlation that's built into GoldSim. And you can see you have a correlation table is available from this element, as well as some sensitivity analysis statistics, including correlation coefficients, regression coefficients, and so forth. And you can also see the coefficient of determination is calculated there. And so another built-in element that provides a way to calculate some summary statistics is the distribution result element. Okay. And an example of the dialog for a distribution result element is shown on the current screen. You can see at the bottom, the lower left-hand corner of this element dialog, there's a series of statistics that are provided by default. The one thing we should note with the distribution result is this is a sample, so results where we'll say the sample is the results from the simulation of the particular value that's given to the distribution result, and it is then smoothing or creating a smoothed or slightly interpolated either CDF or PDF, depending on how you want to show it, from this sample. And so then it's what it's doing is it's providing an estimate of the statistics of the population based on the sample. That would be the results, okay? And so I just bring that up to highlight the fact that the distribution result element is estimating the underlying population statistics. So it may give you a value for the mean here in these statistics that's not exactly equal to what would be the mean for the sample or the individual result values if you took that table of result values and calculated the mean, okay? All right, so now to sort of illustrate some of these time series analysis techniques and some of the sort of special interfaces in GoldSim, we want to look at a few model library models. All of these models are available from our model library, and you can see the path is given on the current slide, and the actual name of the model in terms of the GSM file, the GoldSim file, is given in blue. Okay, so the first one we want to look at is called time history statistics. So let's go to that model. All right, so it should be coming up for you here in a second. Okay, it looks like it's now viewing there. Okay, so this model, again, is from our model library. So this model is doing a number of different things. I guess sort of the main point of this model is it's showing two ways to calculate statistics for time history. That would be using a vector, as well as using a submodel and distribution output. And we'll go through these two in a little detail as we continue through this model. The other thing this model is doing that's a little unusual is it's showing a way to deal with irregular time histories. So in terms of just the general model layout, we're going to look at the time settings in the model. So if we bring up the time settings and the simulation settings, you can see that the main model is a static model. Okay, it's not moving through time at all. All right, and it's just a one realization model. So this main model is just doing one calculation basically, and then it's done. But where all the real calculations are done in this model is in this submodel. Okay, so this submodel, you can see it's triggered, which means with these trigger settings, this submodel is going to run at the very start of the simulation. So before anything else is calculated, all of these submodel calculations will be done. And we can see the time basis for this submodel. So this submodel has its own sort of time. It has its own time settings, which are independent of the main model time settings. And you can see the simulation is for 7,305 days, and there's only one realization. So another thing while we're looking at submodels here is the interface tab is what provides access to many of the time things we would use with a time series analysis. And so what this does is it provides a way to have a separate time basis from the main model. So it provides a way that you can treat your, either create a time series so that it's static for the main model, so that it's already created, or that you can go through a time series to calculate values that then you would use in the main model, okay? So how this is done in this case is you can see there's this time series definition in the interface. And so what it is we have this link, and this is output. So basically this is coming back to this irregular time series shown at the bottom, okay? So we go into this submodel, and of course it's, you know, its own little model, and so this is where the time series for this model are generated. So what we have is we're just randomly generating time series. We're generating one on even intervals, so every day, because that's what the simulation settings are. And then we're generating an irregular time series. And as I page down here to the bottom, you can see the listing of those two time series to see what we mean by even days on the left, irregular time intervals on the right. Okay, so what then is happening in this model is the submodel runs first. It generates those two time series using the random generator, and then the submodel interface passes those time series back out to the main model, and you'll see that these time series are linked to an external time series definition, which is the definition from the submodel. Okay? So then once we have these, then it goes in here, and this is where we look at calculating some time history or some time series statistics using a vector-based calculation via a Monte Carlo or submodel calculation. Okay, so the vector-based calculation, this is very similar to what we saw on that slide, but you can see basically we're using the row iterator to go through and sample the whole time series and convert that to a vector. The one thing with this is you need to know the length of the time series in terms of the number of time indices so that you can create a vector array label set of the right size. But then once you have that, there's a conversion to the vector. And then of course, you can sort the vector using the built-in vector commands, and you can also do a variety of calculations. Okay, in this case, it's calculating the median. For the irregular time series, to do any of the sort of standard time series calculations, you would need a regular time series. So you need it at regular intervals so that you can sort of get rid of the time component and just compare things in the time series in terms of regular intervals. So in terms of lags, so that you know that, everything is at the same time interval definition. And this allows you to use vector operations then to calculate statistics on the time series. From a irregular time series, you can just go through, and we're using a submodel again to do this, but you see basically we're going through the whole simulation again, the same number of days. Each day we sample this irregular time series. GoldSim automatically interpolates between values, and that creates a regular time series. And so that's what then the statistics are calculated upon. Okay. So we saw the vector-based statistics. So basically we converted the time series directly to a vector, and then we did statistics calculations on that vector. Another way you can do it is you could use a submodel. And so here we're going to use the number of realizations to essentially walk through the time series. So you can see this submodel is a static submodel. So no elapsed time. However, it has a number of simulations, or I'm sorry, a number of realizations, which is equal to the number of indices in the time series. So then you see we have our time series, which is just linked. It's passed in through the submodel interface, and it's linked back all the way back out to this time series. Okay. So then it's passed in here, and we just sample this time series using the realization rather than the row iterator to walk through time and basically say, okay, this is the value in the time series at time 0. It goes in, that's what we're looking at now. Then the next realization we'll look at time day 1, time day 2, and so forth. So really this realization based submodel looking at going through a time series, it's doing the same thing essentially as the vector. It's just converting the time series to a vector, but it's doing it, one index at a time rather than the whole vector, okay? So then you can see we have both vector-based and submodel-based time series, or ways to convert a time series to a vector for calculation. For the vector-based, you don't need, when you do this method, what's in this vector statistics calc container, you don't need to iterate through the time series, right? So you're doing the whole thing. You're taking the time series and converting it directly to a vector, no iteration. That's good in one way because it's probably faster. It's bad because you would need to have, basically you'll have 2 copies of the same values, okay? The other sort of con with this approach is it doesn't provide you the facility to get to a distribution result, which may or may not be needed, but if it is needed, then you would want to use the submodel approach. And I'll show that, what I mean by that here in just a second. So then for the submodel approach, where we're using a realization to step through the time series, it's only taking one time series index at a time, and so there's not two copies of the time series essentially. So that's a good thing. The bad side is you are iterating through the time series one index at a time, so you have that loop, and there could be some more calculation time involved with that approach. The one thing I should point out is we did talk about distribution, and so that's this part of this model. And again, that is from the interface. So if we look at this is just the current index output inside the submodel, and we'll look at that in a second. But that's just the value for the day corresponding to the current realization number. It's the value for that day, and so rather than outputting the last calculated final value, we're outputting the distribution. So it's collecting all the values from each realization and providing those as an output. You can then link that to a stochastic element or directly to a result element, either way. And you can see both are done here. Okay, and you can see the result, what's shown here then, and so then this provides a way to get access to sort of the distribution result for that time series. Okay. All right, so I think those are probably the important items for this model. And again, it's showing a good example of using this combination of a static calculation and a dynamic calculation to go through a time series and calculate statistics on it. It's also showing different methods of doing time series basic statistics calculations. Those would be vector-based or using the submodel-based. Again, it's pretty much the same sort of thing. It's just the submodel is looping through using the realizations. The vector, you're converting the whole time series at once to a vector. Okay. And it also shows how to deal with irregular time series histories and shows a very easy way in GoldSim to get a regularly sampled time series from an irregular time series. All right, so let's move on and look at our next model library model. Okay, so this model library model is called time series pre-processing using submodels. And let me bring that one up here. All right, there it comes up. Good, it looks like it's up for everyone now on their screens. This one talks about pre-processing, and the idea with the pre-processing component is, we have this data time series, and actually in this case we have 3 data time series. We have rainfall, runoff, and evaporation. And you can see these are locally defined, over 29,000 entries. And so there you can see the data in the time series. Okay. And so we have these input data, so we know these all at the beginning. Before we start the main model, the idea here with pre-processing would be, we want to find out some statistics based on these time series so that then we could use those in our bigger model. And this is an example model, so it's only showing the pre-processing part, but theoretically you could have this linked to a larger model where you were then using the statistics calculated in these submodels to to do some sort of simulation or using them in your simulation. Okay, so we have 2 submodels here, and one is calendar-based and one is Monte Carlo-based. So this is again looking at the whole thing of using realizations to iterate through time, which would be the Monte Carlo-based, versus actually just stepping through time, which is this calendar-based. So you notice this calendar-based one has the same number of days, the duration for the time series. So basically it's just going through the time series a day at a time. Okay. Again, you can see the interface. We're passing in these time series definitions. We're not passing anything back out, but we could be if it was needed in the larger model. Okay, so these time series here are of course just linked back to those external, so basically linked to the interface, and so they're just a link essentially pointing back to these 3 data time series. And we're just sampling each one, okay? And what I mean by sampling is we're just, oh, here's the current date time, get the value for today, and this is based on the calendar time submodel. An alternative way to go through that would be to use a Monte Carlo simulation. And you can see here, runs with a Monte Carlo simulation that has the same number of realizations, essentially, as days in the time series. Okay, and both of these are triggered when the model starts. You see Monte Carlo, there's the number of realizations, equal to the number of days, and it's a static model. So what that means is it's not going to go through time at all, but it's just going to go through each realization. And again, here you can see this thing of using the realizations to essentially make the interpolation date time to get the value out of the time series. And this is just stepping through an order. It'll go day 1, day 2, day 3, and so forth. And what happens then is you can link these to a multivariate plot, okay? And we'll look at those in a second with the dashboard we have. So there's one other thing that's going on in this example model, and that's these main time series have time shifting enabled. And you can see it's annual, but uses a random starting point. So we know that these time series and go from 1932 to the beginning of 2012. And our simulation settings for the main model is just 730 days. It's a period within the data period, but we're going to use shifting, and so it's going to just randomly select basically 2 years to simulate from the data. Okay. So let's look at the dashboard real quick for this one. And I need to run the model in order to see the scatter plots. And so that's really what I wanted to show here. So let's look at rainfall and evaporation scatter plot. And this is just the multivariate element. Okay, so you can see what then we have access to is you have a table. And so as you can see, this scatter plot, this is where we're going through, a day at a time and sampling the time series, right? And so there you can see all the time series, but now in the table, it's essentially converted to a vector. Index 1, of course, would be 1/1/1932, and so forth on down. The other thing that this gives you is a correlation table, so you can see how precipitation and evaporation are correlated, and that, of course, would be the correlation between the values for each index, okay, or each day. You can also see some of these sensitivity calculation statistics. The correlation coefficients reproduced here, but then you also have some regression coefficients and a coefficient of determination. Okay. And so one thing to keep in mind, and so that is from this plot here, and so the multivariate element itself needs to, it won't take a time series directly. It needs to, basically it wants a value for each realization in a Monte Carlo simulation. And so that's why we're using that Monte Carlo submodel. But once you give it that, then it will do the correlation calculations for you. Okay. So the other thing that we have is we did have the random shift. And so you can see the main model just runs for 2 years, and it's arbitrarily selecting a year from this long, 1932 to 2012 time series, are arbitrarily selecting 2 years to use for the values here. And that's what's plotted here with this random annual time series shift. Okay. All right, so let's move on and look at another model. And this model, we're going to look again at the scatter plots. And so this model is appropriately named scatter plot. Okay, so the scatter plot model should be up for everybody. And so let's look at just sort of the time bases on this model. And it's an elapsed time simulation for 100 days. So you can see what's happening is we have these stochastic elements, okay, and they're just resampled every day. And then we're recording a time series from those. So we're recording the output history here from price, okay? And we're triggering the recording unchanged. So every day we're recording the value, every day it's resampled, so that's giving us a recorded time history of price and demand. So those are then passed into a submodel. You'll notice the triggering. This submodel is triggered at the end of the simulation. So this is important because we need to have all the time series values recorded before we run this submodel to then analyze those values. Okay, so we have the submodel triggering at the end of the simulation after we've recorded the time series values we want. You'll notice it's static, so it doesn't go through time. It does have a number of realizations though, and that will be equal to 100, and so it's going to go through each day and sample these time series. Again, on the interface, you can see that the time series are passed in and the number of realizations value is passed in. And this value is just the number of days, okay? So then we go into the submodel, and so the submodel goes at the end. These time series are just linked to these definitions. So we need these to be completely populated. That's why the submodel runs at the end. And then you can see these values. We're just sampling each realization we're using as a day to step through day by day the time series. And so for each realization, then we collect these values in the multivariate properties result. And so you can see the plot on the screen that you'll get for the final output. And again, if we run this, and look at this, again, we have the table now, so showing the vector of the values. And we have correlations and sensitivities. You can also change these calculations to use ranks, so rank-based statistics, which can be very helpful sometimes. Okay. So then the submodel plot is essentially generating a comparison of price versus demand for each, and each point represents that comparison for each day. Okay, I want to move on and look at another model. This next model is going to be called post-process time history statistics. Okay, so a little bit simpler model than some of the ones we've looked at so far, but don't let that confuse. Don't let that mislead you. It's actually doing something fairly complicated. And a lot of times, as I mentioned, you'll see these example models say post-process or pre-process, and really that's what that's saying is, where is the time series generated, and where are we processing it? So here we're generating the time series with a submodel that is running right at the beginning, and it runs for 100 days, and it runs for 500 realizations. The main model is static. So GoldSim will know to have this run first because this time series output requires a definition from within the submodel. If we go back and look at the interface on the submodel, you can see what we're getting out is the statistic history. So we'll look at this, and it's a time history. It's what we're getting out, and we're getting out the statistic history, and we've selected the 99%. So this would be the 99th percent largest value each day is what this time history is. Okay, and you can see you can get all realization histories, or you can just get the last calculated. We could also change this to be final value. In this case, we want this 99th percentile value. If we go in here, you can see there's just a random it's flow rate in this case, but so this is just sampled each day for 500 realizations, and then pulling out the 99th percentile time series or time history, and and using the definition from the submodel to get this time history into a time series element, which then lets us convert it to a vector, which we saw earlier using the row iterator. And then, of course, we can actually do a statistics calculation on the vector using one of the built-in methods. Okay? And so if we run this, basically we get the average value for the 99th percentile daily flows. Okay? All right. So there's two more models I want to look at briefly. And I see there's a couple questions over there. And the I'm going to actually, okay, so let me actually address these questions here, will probably be better. So one question is, does it use concurrent time periods from all time series element when it arbitrarily chooses a period? It will not, it will, that's back to the previous model, so let me bring that model up. And that would be, is that this one perhaps? Yes, that's this one. Okay, so we can see we have these settings here. Each one will start at a different place, potentially, I believe. And we can check that by, if we look at, so 118.73 for runoff. So if you wanted to actually have them start on the same, then you could use this same data year to start in. So that's how you would have them start on the same date. Okay, but they do, each one would choose its own random date. All right, and then there's another question, there's a basic question, what is the connection between time step, simulation, and realization? And so what that is, let's go back to the other model. Just give me a second here. Let's go. Okay, not the model I wanted. Let me try this one. Okay, so this one will potentially, no, this one's not going to show it other than, let me try one other thing here. So this one will show, so you see realization here. So this realization is going to start at 1 and go up to the number of realizations. In this case, it's equal to the number of days, which is 100. So first realization, this realization number is going to be 1. So we have 1 minus 1 is 0 times 1 day. So that's times 0, right? So 0 days is what that equals. The next realization is going to be 2. We have 2 minus 1 is 1 times 1 day. So that's going to be the value at day 2. And so that's how we're converting from time to realizations, right? We have this time conversion factor in here. We have to know what the time basis of the time series or time history is to use that. All right? Okay, so I'm going to move on and get through another model or two here, and then we'll continue with some more questions. The next model I wanted to show is again about some data pre-processing. Okay, this is this model again. We're going to have a data time series. You can see it's all defined here. See the number of time records. We're going through calendar time, but before this main model goes through calendar time, we're going to have a submodel that runs. It's bringing in that time series and it's passing back monthly averages. So this I just wanted to show this calculation. You can see here with the discrete change elements, this is a good way to go through a time series, or a good example calculation for going through a time series and extracting discrete events. This could be, for example, you could use this sort of approach to extract the number of consecutive dry days, consecutive wet days. You could use a similar approach to do the maximum annual of something. You could also use the extreme element, would probably be an easier way to do the maximum or minimum, but this approach is good for if you want to count something up during a year that's not happening regularly when you have to determine what it is. So I think the number of dry days, consecutive dry days, would be a good example. And we're not going to go through the details of this. It's fairly involved, but I think it's good to know that just this is a good example model to see this sort of calculation, and you could easily modify it to do the type of calculation you wanted. Okay. So this is getting those monthly statistics using the submodel. That comes out here, and then it's just sampled each day using this, basically the average for the month. Okay. Again, we're using a submodel that runs beforehand to do our processing, and then we're using those processed values in a later main model. All right, so one more model library to look at just briefly. This one's going to talk a little bit more about the distributions. Okay, so this submodel is all about generating statistics using a distribution. So again, what we're having is we'll have a main model, static, submodel. It's also static, but runs for the number of realizations from these total days. You can see again, we're taking the start time plus the current realization times days, and so this is going through this time series using the realization to go through each day. And so it'll have the number of realizations equal to the number of days, and it samples those. Then in your interface, we're again getting the distribution of that sampled value back out. You can then either put that to a stochastic element, or you could just go directly to a distribution result element to see it. If you go to the stochastic element, then you can use the built-in functions to calculate some values. This is showing the little plot there at the right side of the screen is showing the statistics for the underlying population from the distribution element. Okay. So before we wrap up, I want to go back and look at a couple more slides just to quickly talk about some sort of caveats with time series analysis in GoldSim and just with time series analysis in general. So give me a second. Let's go here. And there we are. All right, so here's where we left off. We went through these models, looked at various analysis techniques. So I think the really important thing to keep in mind with time series analysis is definitely kind of an art form. There's not really each one is different. The correlation between this adjacent time values is probably different, and it's one of those things where you're just gonna try a bunch of different things and see what works. So it's really not a cookbook type approach. Okay. The other thing to keep in mind with the if you are analyzing a time series, that is a calculation, and there'll be a lot of assumptions that go into analyzing that time series. And so if you're analyzing a time series, that's essentially a separate calculation from what you're simulating with the model. And so just keep that in mind. A lot of times you could hide a very detailed time series simulation in another very detailed model, and then it can be very, very difficult to figure out what's going on. And so in sort of a final analysis or note here and just sort of general caveats, oftentimes people think about extreme event analysis, so like, maximum annual flows or maximum annual 20 or annual maximum 24-hour precipitation in terms of time series, because you are looking at things that's the maximum of a year. But it's actually, that type of analysis isn't really time series analysis. It's more of a classic statistical method. And kind of the differentiator there is for extreme event analysis. The order of occurrence doesn't matter. You just want to show with the order that that the successive observations or successive extremes are independent, right? And why that is that whole analysis component for extreme events is you're basically going to fit a theoretical distribution to your sample. And for once you're fitting a theoretical distribution, they need to be independent random events. Okay. And so I think the only point there is extreme event analysis is sort of a separate thing. It's often thought about as a time series analysis just because it involves time, but it's not really. Okay. A few things about GoldSim in relation to time series analysis. GoldSim is really good at dynamic simulation. That's big strength of GoldSim, and that's what it's designed for. So it's not as optimized for sort of static statistical analyses. If you would want to do that type of very detailed in-depth calculation, R is available for free, and it's very powerful, and it's very good at static calculations. The other thing with statistical analysis of time series is that really for everything we looked at today, you're basically converting a time series to a vector, because you really just want to look at things in terms of lags, and they need to have equal orders, or that needs to be a filled time series in terms of having regular time intervals, and then you can just have a vector, and that simplifies your calculations. This conversion is not difficult in GoldSim as we've seen, but it does require the length of the time series, and you might have to use realizations to kind of loop through your time series, or use a vector constructor like that row object we looked at. In terms of, again, just traditional methods of time series analysis are generally concerned with decomposing variation in a series into components representing trends, seasonal variation, and cyclic changes. I mean, this is very much of sort of an iterative, try this, look at it, does that work, does it not? Okay, let's try something else, let's try something else. And so it is just sort of this iterative series of static calculations, and not as often a dynamic process simulation. Okay. A specific caveat related to GoldSim and cyclic analysis or harmonic analysis is GoldSim doesn't have any sort of Fourier transform capability, so you couldn't do this sort of classic spectral analysis that you might do for a time series analysis of certain types. Probably the classic example of this would be tidal analysis. Okay. Another maybe point of interest if you're thinking about using GoldSim for time series analysis is you can do lag-based statistics. So many of the sort of advanced time series analysis methods are concerned with, what's the correlation between something at lag 1 day and lag 2 days, or is there something throughout the time series at that sort of 1 lag, 2 lag, 3 lag correlation, right? You can do this type of statistical calculations in GoldSim, but it is pretty much a manual process in terms of you're going to have to order the lags and come up with the various mapping and so forth yourself. Some time series analysis packages and computer package that are specifically designed for that would let you do that type of calculation with just a basic function. So that's something to keep in mind. You could do a lot of work on something like that in GoldSim where you might save yourself some time if you were interested in lag-based statistics by using a different package. All right. So one last thing I want to bring up here, and this sort of relates to the extreme event analysis and to the distribution result elements in GoldSim. So the thing to keep in mind with the distribution result element is it's taking distribution result element is going to take a sample of values, which are just the results from each realization for a specific item in the model. Okay, so it has that sample of results. It's then going to create a continuous distribution, or going to create a distribution from those results using some internal algorithms. And part of that, it will probably do a little interpolation to kind of smooth the results to make a nice CDF or PDF. Okay, so what that means is, because there's that smoothing process in there, the basic statistics in a distribution result element, like the mean, are actually an estimate of the mean for the population. It's not actually a calculation of the mean for the sample. All right. So you don't really, there's no reason to expect that the mean in the distribution result is exactly equal to the mean if you took that sample in terms of all the simulated values and just did a straight mean calculation on those. Those two means might not be exactly equal, and that's purely because the distribution result element is trying to estimate the underlying population mean, not the sample mean. Okay, and there is a good knowledge base article on that, and you can see that knowledge base article at the address listed here. Okay. So when GoldSim uses the distribution result element, it is empirical, and so I think that's important for thinking about extreme event frequency. It's not usually with like an extreme event analysis, you would want to fit a theoretical distribution to a sample. So GoldSim isn't fitting a theoretical distribution, it's just estimating a distribution based on the sample with some smoothing. You could, and so basically all we really want to say there is it is a different procedure. You could use a stochastic element to estimate a theoretical distribution using a parameter. So like the classic example of that is the exponential distribution using the mean of a sample. And so, but that's basically, it's not, what GoldSim is doing in the distribution element is not the same thing as that. It's just calculating a smooth distribution based off the sample, not fitting a theoretical distribution. And I don't want to go into that too much more. And so this last slide is also just talking about that, how there's not a theoretical distribution fitting algorithm in GoldSim that's built in. You can use it for simple sort of method of moments fits. Again, the exponential distribution fit using the mean of a sample is a good example of that. But I don't think we're pretty much out of time, and this is kind of an accessory topic, and so we probably don't need to spend too much more time talking about that. I want to leave just a moment or two for questions. If anybody has any more questions, feel free to ask them now. In this wrap-up page, there is a couple more model library models that are helpful in terms of looking at reporting periods and time shifting, if anybody has any questions about those. All right. So that's going to sort of wrap up what I have for today. There will be a recording of this posted on our website. And of course, if you have any questions, I'll be online here for a few more minutes and happy to answer any questions you have. You can also send us an email at any time with other questions.